I want to continue our discussion of sampling concepts. We talked about the difference between a population and a sample, a census on Wednesday. And we went over some situations where it would be more beneficial to use a sample as opposed to a census. Things like cost, whether or not we have destructive testing, whether or not we have reasonable response times, or whether or not we're dealing with sensitive information. But why do we do samples? What are we actually after? Well, the whole purpose is to find out stuff about the population. Some characteristic we want to know about. Oops, wrong button. That one. When we're talking about the whole, we're going to call those things parameters. A parameter is a measurement of our population, some characteristic within it. So we were talking about height on Wednesday. I want to know the height of a college student. I could be asking for an average. I could be asking what fraction of college students are below 18? What fraction of college students are above 23? I want to know these things, right? If I'm looking at a numerical item, quantitative data, whether discrete or continuous, we usually indicate that with a Greek letter for a parameter. So things like mu, the letter M, for an average, a mean. Those of you that have seen some statistical information may or may not have heard that term. Mean is just a fancy word for average. A sigma for a standard deviation. And if you don't know what that term is, I promise I'll define it eventually. Here's the one that makes me absolutely crazy. I want something for proportion. Wait a minute. Mu is an M, sigma is an S. I want a P for proportion. That's a number, dang it. No. In this class, pi's a variable. Makes me nuts. Twitch. So if I wanted to know what fraction of college students are over the age of 23, and I look at all college students, I do a census, and I have complete information, that numerical parameter is the proportion of students over the age of 23, that's pi. But most of the time I will do a sample because I really don't know that I can get at all college student demographics. I'm not the federal government who gathers all that information. We might not have a Department of Education to gather all that information if the current administration has its way, but I don't have that information. So I'll do a sample. When I look at characteristics of my sample, please notice now, the population size is capital N, sample size is little n. I can actually compute these numbers. I can say, let's look at ages of college students at Seton Hill, because I can get those from the registrar's office. And then I say, how many of the students registered at Seton Hill this semester are above the age of 23? That's my proportion, but I'm calculating it for the sample, not for the whole group. So instead of using Greek letters, we normally use Roman and Latin letters. Now, I would love to tell you that means I'm going to use M and S and P, but they're going to mess with me right away. And so for an average, for a mean, I'm going to use that symbol. An X with a bar over it. I am going to use S for a standard deviation. And I am going to use P for a proportion. But sometimes it'll be, I don't know, we'll call our variable that we're looking at, we'll call it Q for quality control issue. Or we'll call it B for batches of something. We can call it whatever we want, but what we'll use is a Greek letter when we refer to the population and a Roman letter, quote unquote, normal letter for the sample. The things we get, these things, shouldn't really be called parameters anymore. Parameters are for the whole group. I need to change that word. Yeah, let's scratch that out. A parameter describes my whole group. If I'm just looking at a subset, my sample, we're going to call this a statistic. So something I actually calculate for my sample is a statistic.
For the X, the S, and the P, are they capital or lowercase?
They're lowercase.
Okay. All of those can look the same.
Yes, I understand that. Thank you. Good catch. I tend to put feet and serifs on my capitals because I don't have lines on my paper. So as weird as it sounds, when I actually write an S and I want to make sure you all know it's capital, I'll do something stupid like that. But I am rarely going to use capital letters for variables in this course. If I had lines, it'd be a whole different story. Other questions? I can get at the information for a statistic easy. I can do a survey at Seton Hill. I can ask about the students here and try and use that to reflect on the student body across the country. Or I could go even further. I could use a couple of classes. I could say, just look at the students in the School of Business. Just look at the students who are taking math courses this semester. And I could ask the same question. That's my sample. And then I do some calculation, I get a statistic. Here's the question. So what? I got a number. Yay. What's the purpose of the statistic I just calculated? The proportion of students in the School of Business at Seton Hill that are over the age of 23. I'm going to use that number for.
Is it for federal loans? Because most of them, if they're over the age of 23 or then they most likely, or they might not live at home and stuff like that.
What? But why would I need that? That would be the finance office, right? But does that help me outside of Seton Hill? Remember, my first question was about students, period. But all I have access to is here. So I did the sample. I don't have access to the population. I have access to a part of it. I'm hoping that my sample is reflective of the whole group, that I can use my statistic, estimate my parameter. And in a very real sense, that's all a statistic is. It's a guess at what we think is going on in the bigger group. I think the proportion of students over the age of 23 here at Seton Hill is reflective of the proportion of students over the age of 23 at colleges and universities nationwide. I don't know if I'm right or not. But the assumption we will make is that my goal is to use my statistic to figure out what's going on with my parameter, to estimate my parameter. What goes into that assumption? What are some of the factors I need to worry about when I make the assumption? What's happening here at Seton Hill is reflective of what's happening at colleges and universities across the country.
Have to make sure that the standards to get into, or the same standards to get into.
I need to make sure we're a representation of the population. I need to make sure that I've got a good sample, that I really think, hey, what's happening here is reflective of the broader community and not we're a very exclusive school. You got to be really good to get into Seton Hill, or we're a garbage school. We take everybody. I don't think we're either of those things. So hopefully we are reflective of the larger institutions. Even if I'm not just looking at universities, let's think about the difference between the population and the sample. My population is everybody. My target population are the people I'm interested in. If it's something with my handwriting, you got to tell me so I can fix it.
I wouldn't look again show why like the way the parameters.
So parameters only apply to the big group. Statistics apply to the small group.
Okay.
That way, when I say the parameter is 50%, I'm referring to the whole group, and then I go, oh, well, I looked at my sample and my statistic is 49.3%. Is that a big error or a little error? And we'll look at what those, how we get those answers further down. You're welcome. So I really don't always have the ability to get at the entire target population if we take our sample. So that means we need to define a sampling frame. This is the group from which we take the sample. And just a moment ago, I was using students at Seton Hill as my sampling frame for students at colleges and universities countrywide. Ideally, this should match my target population as closely as I can. I would like there to be very little variation between the type of individual in my sampling frame and the type of individuals in my population. How do I get that group? How do I decide what my sampling frame is? We could use a phone list. I'm going to call people and ask them survey questions. If they don't hang up on me right away, hell, if they answer their phone in the first place. I could get a database of people who have opted in to receive email. Check here to receive more emails from this company, right? Maybe you're on a list and therefore I can mail you something. Maybe I'm doing something related to voting. I can go look at the voter registration database. I can look at whatever list you've volunteered to be a part of or were put on automatically, and I can do that. One of the most famous surveys done was on the winner of the presidential election between Harry Truman and his opponent. The New York Post, the newspaper ran a headline, Dewey defeats Truman. There's a picture of Harry Truman holding it up the next morning when it was wrong. Truman won by a substantial margin. Why was the newspaper so wrong?
They were taking a sample size, and in that sample size, Truman wasn't gonna win.
Well, they actually had a really big sample. So it wasn't the size of the sample, but it was how they got the sample. They did their sample by phone. Somebody with a computer or a phone in front of you, when was Harry Truman president? That's why you have a computer. I don't expect you to know this stuff off the top of your head. It's in the history class. Yeah, what year? Right around the Second World War. Perfect. So this is the late 40s, early 50s. Tell me, how common was a household phone in the 1940s? Very few people had a phone. Phones were expensive. So if you do a phone survey, who are you going to get? All the rich people. Guess which party they didn't vote for? Truman's party. So they had a biased sample. Wasn't that it was small or that was badly received. They picked a sample in which those people aren't going to vote for this guy's policy. So, if I am looking at, here we are, problem number 17. The target population is all stocks in the Standard & Poor's 500 index. Is this a parameter or a statistic? The average price earnings ratio for all 500 stocks in the index. A parameter or a statistic? Key word in that sentence. Because all. That's the whole population. The proportion of all stocks in the S&P 500 index that had negative earnings last year. Well, you either had negative earnings or you didn't, right? So that would cover. Yeah, there's that word all again. So this really is a parameter, isn't it? How about the last one? The proportion of energy-related stocks in a random sample of 50 stocks. I hear it. Because it does literally say sample. So we knew we didn't take them all. So knowing what I've got when this number is presented to me, does it describe everybody or does it just describe some of them? Helps me then attribute correctly which group I've pulled from and allows me to make more or less accurate statements about my population versus my sample. So how do we get our sample? There are lots of different ways we can acquire a sample. They really fall into two main categories. Some randomization or non-random behavior. Again, I'm going to use capital N for the whole population and lowercase n for the sample. One of the gold standards in sampling is a random sample. I want to have as little bias as possible. So there are several different kinds of random samples. Let's start with a simple random sample. The word simple here refers to the idea that each individual in the entire population has the same chance of being selected. So really all I have to do is number them. Let's say you've got 2,000 people. I want to select 12 of them. I put the numbers from 1 to 2,000 in a hat, and I draw 12 numbers. Take one of those bingo barrels, right? Turn all the balls in them with all the numbers, like they do at the lottery every night. All the balls bouncing around in there, right? I could use a random number generator. Excel has a function that generates random numbers. If you type that into an empty box in Excel and hit enter, whatever numbers you put between A and B for A and B, it'll generate a random number between A and B. What's interesting is that the method by which Excel generates random numbers isn't all that random. It turns out that way back again in the 50s, the Rand Corporation, a statistical analysis company, created a book, a physical book called Random Number Tables. That book was the starting point. People took those pages, flipped the book open wherever they wanted, dropped their hand on the page, said, this is the number. And that's where they started. And they just kept going from there. So you could legitimately follow along in the book if you knew where they started from. This got a couple of people into a lot of trouble. One of the slot machines companies used that sort of a table as a randomizer. And then somebody who worked for the company knew where they started and therefore knew when the jackpots were going to happen. Could just watch how many times this machine had been played, step in, play one roll, and win. So, we really look for a lot of other methods to make things more random or to affect the randomization better than just using a table. We've gotten a lot of new math about random numbers. If you're more interested in that, talk to me after class. There's all sorts of neat that goes on there. But let's say I do this and I want 12 numbers between 1 and 2,000, right? Let me open up Excel. Share it in here so we can see it. Come on, allow me to share. Share Excel. Bing. Blow this up. Make it larger so you can actually see what I'm going to type. Equals. RAND between. See, it even starts to auto-complete the word for me up there. Rand between 1 and 2,000. I want a dozen of these. So copy, paste. There you go. Now I happen to pick a very big range, right? 1 to 2,000. But if I told it I wanted numbers between 1 and 10, and I asked for a dozen of them, what could happen?
Guarantee that.
I should have more than the same number more than once. I could even get that here, right? Here, let's run this again. Paste. Nah, nothing doubled up. No, nothing doubled up again. I could do this over and over. It is quite possible I get the same number more than once. So we really have two different types of sampling. It's down here. Depending on whether we allow a number to be picked more than once. So imagine I have a deck of cards and I say, pick a card. You look at the card, you put it back in the deck. I shuffle the deck and turn over your card, right? I'm not good at magic. I'm not going to do this. That's why I didn't bring my deck of cards. But I could say, pick two cards. There are two different ways I could do that. Pick one, look at it, put it back, reshuffle, pick the second one. Or I could say, pick two at the same time. Without replacement versus with replacement. Well, wait a minute here. Excel allows for repetition. I don't have an Excel method that forces me away from repetition. Frequently, what people will do is they will over-select. If I need 12 numbers, they'll select 15. If I need 100 numbers, they'll select 150. They'll over by some margin. Every time they run into something repeats, they throw it out. Since we were talking about doing samples for things that were destructive testing, yeah, if I'm working on a car bumper and I'm going to run it into a wall and see how good it is afterwards, I'm not going to do it multiple times on the same bumper. That's not going to teach me very much, is it? Or I have to do it until the thing breaks. I can't do it more than once. I spent a summer working for a pacemaker company. This company was building a defibrillator. You know what a defibrillator is? You have the two paddles, clear, restarts somebody's heart if they're in arrhythmia. Well, it reboots their heart. It doesn't restart it. It reestablishes the electrical connections. Only they didn't want to build one like the one on the wall out here that says AED, automatic external defibrillator. They wanted one that was inside. The big problem with internal defibrillators is that you actually have to attach those paddles to the surface of the heart. And that meant you had to saw through the chest bone, open up the rib cage, sew this little metal mesh panel at the top of the heart, and sew another one to the bottom, because that's where the two major electrical pieces are in the heart. That's why when you use the paddles, one goes down here, one goes up here, so that the electricity goes through the heart from the bottom. We had a roll-up patch. We were going to roll it up in a tiny tube, run it through the blood vessel of the vena cava into the upper atrium of the heart. Open it up and pin it to the top on the inside of the heart rather than the outside. We could still do the bottom one. That's not a problem, because the bottom we can get through right here under your rib cage. We don't have to saw through the middle of your bones. This, by the way, would lower your recovery in the hospital from 11 days to 2. I was required by FDA regulations to take one of the wire leads and test it until it blew up. I'm not going to be able to repeat that sample, am I? By the way, it took a lot of electricity to blow that sucker up, about 450 joules. When you use them inside the body, you started around 10. We were really cranking this sucker. But that's the sort of rationale you're going to need to understand, should I allow repetition? If I'm doing a survey on your opinion of the dining hall, does it make sense to ask the same person 3 times? They're a very different set of skewed opinions. But there may be cases where taking the same sample more than once is useful. I get a benchmark. Oh, I've seen this one before. Did I get the same result both times? Medical testing does this a lot. This is particularly important when the sample size is close to the population size. If I need to take at least a dozen samples to get good information, and I only have 20 things, well, then maybe repetitive sampling will be useful. But this will bias the result, so I need to be careful about that. Most of the time, what we look at is this ratio. What the hell are those letters again? Little n, capital N?
The small ones for statistics, big one for the whole group of population.
Right, so but this is for the sample size, and this is the population size. So this is how many we took out of how many we had. And we want this to be small. Ideally, we'd like it to be less than 0.05. Now, 5%, we literally made that up. Somebody in statistics decided a long time ago 5% was good enough. Usually, in this case, we will consider our population to be effectively infinite by comparison to our sample. So in our case, it's really unlikely you have an infinite anything when you're dealing with real objects, but it's big enough that's effectively infinite. Chances of my repetition go down a lot. I'm usually only going to worry about repetition behavior when that ratio, little n to capital N, is much closer to 1, 0.7, 0.8, 0.9. Then I can start worrying about how to adjust for the possibility of repetition. Questions? To show you how high-tech the pacemaker company was, we had 6 wires. We rolled a die. That was how we picked it. That was the one we were going to test to destruction. We sent the other 5 to the lab to be tested for live implantation. They were sent to Australia. Unfortunately, they got lost along the way. They never got tested. When we have large populations, like quality control issues, you may simply say, I'm going to take every 100th, every 10th, every 15th. I have a full auditorium. I'm going to take the people in the second seat in every row from the right. There you go. That's a sample. If I have some sort of organization to my items, I've got an alphabetical listing of the students here at Seton Hill. I'll go through and pick every 10th one, send them a survey. That might be a lot. Maybe we'll go with every, I don't know, 15th one. So here, I'll pick every kth item in the list. I don't know what K is. We'll figure K out as we go along. Ideally, though, K should be the population divided by the sample size I want. If I want 100 surveys sent out to the people at Seton Hill, there are roughly 1,500 undergraduates here. So I should send out 100. I should pick every 15th person. 1,500 divided by 100, every 15th person. But if there's some periodic nature to our data, that won't work for students. Students are all different. But if I've got something that repeats, seasonal behavior, or something where I like, okay, take something from machine 1, machine 2, machine 3, machine 4, and then they all get put in a row, and if I pick every 5th one, well, that would work. But if I pick every 8th, I'll only be getting from machine 4. Oh, okay. I have to be careful about overlapping behavior like that. It's not common. Spending habits. One of my absolute favorite useless studies showed that people make a lot more ATM withdrawals on Fridays. Gee, I wonder why. Because you get paid on Friday. There's no deeper reason than that. Their paycheck showed up, they went to the bank. If I have a system, I have to be able to have enough flexibility in that system to vary it if I need to. Questions? Stratified? The hell does that word mean?
Formed in or arranged into strata or layers.
Layers. The strata, let's suppose that our population has some distinct subgroups. And I want to make sure I don't just sample within one subgroup. I could say, oh, What I really need to do is I need to look and make sure I get some from each of the subgroups. We're just talking about 4 different machines, right? I need to make sure I didn't only get samples from one machine. I need to take samples equally across all 4 machines for my quality control. So what I could say is that if I have layers or strata, groups, now I just used another big fancy math word there, homogeneous. A uniform, really, that's all that means. Homogeneous subgroups, in this case, means uniform. So I would be like, oh, I want to make sure I have enough of a sample to account for demographic changes, younger, middle-aged, older. So I don't know how many subgroups I have, but I could say, oh, we'll take our population and we'll look at the different subgroups, N1, N2, all the way up to an L, L for layers, we'll use L. And then I can say, okay, what I really want to do is I want to take a sample out of each group. Little n1 and little n2, all the way up to little nl. And ideally, the proportion I take from each group will be the same. Ideally. So if there are 1,000 people and there are 400 in group 1, 100 in group 2, all right, wait a minute. I want 40 from group 1, then I only want 10 from group 2 to try and keep this proportion the same. Questions? It isn't always possible to predetermine the differences in your respondents. So here's an example from the text on vaccination rates. MMR, measles, mumps, rubella, a childhood vaccination. And when I go and I look at my population, the population itself is 55% male and 45% female. There are 2 different things I could do. I could create a list of people I'm going to sample. Let's say we wanted a sample of 200 people. I could say, what I really want to do is I want to make sure I get 110 of them to be male and 90 of them to be female. Well, then that would reflect the appropriate breakdown of my population. The other thing I could do is I could do a truly random sample. That includes a demographic question. Is the respondent male or female? Then I could make a pile of all of the male responses and all of the female responses. And it wouldn't matter how many I have in each one. And what I can do then is I can multiply the numerical data I get from the male responses. I can multiply by 0.55. And the females, I can multiply by 0.45. And then this weighting the weights on my data reflect the proportion within the population. And that means I don't quite have to sort my samples quite so hard. I can simply do the sampling and then skew the results to reflect the population better. This happens a lot in demographically driven surveys. Surveys that ask you for your gender, your race, your income level. I don't know if you've taken any surveys. The following questions are all demographic. They're going to go through and then figure out which category you fit in. And then we'll say, well, we know in the state of Pennsylvania, we have this many people over the age of 50. So that percentage of the population will multiply by an appropriate weight. Questions? One type of stratified sample is called a cluster sample. So I could divide the county, Westmoreland County, up by school districts. Oh, I want to take a sample from Penn Trafford, a sample from Greensburg Salem. I can go through and look at all of the different school districts. And then, okay, now I know I've got proportions that way. Let me make sure I've used those as my layers. By the way, this sometimes saves on money because then I can say, I'm here in this school district. This is how many people I need. Now I can go to this school district. This is how many people I need. If I'm doing a survey, I can go from block to block to block. Maybe I need this many people in Allegheny County, this many people in Westmoreland County, this many people in Beaver County, and so on. I can do that geographically. But if I'm trying to do a layered sample, I may say, oh, I've got 57 counties. Rather than sample all 57 counties, let me sample 10 counties. We then pick those 10 counties and then figure out how many we need from each one. There's a lovely illustration about cluster sampling on page 39. I'm going to sample 4 people from each of the 3 districts. So I go and I check my 3 districts. Those 4 people were randomly selected from each of the 3 districts. But I only chose 3 districts out of the 1, 2, 3, 4, I don't remember how many there are, out of however many there are. Cluster sampling is useful when dividing up other strata is a pain in the neck. Figuring out what the demographic differences are could be quite difficult. Regional variances make this relatively accurate. You'll hear often, Westmoreland County votes this way. Allegheny County votes this way. The state of California is regularly this party, right? That's making the news all over the place. That's what they're doing. They're cluster sampling that area. I am sure you will meet a Republican somewhere in the state of California. Arnold Schwarzenegger. I'm sure you will meet a Democrat somewhere in the state of Texas. But I can make some gross generalizations based geographically. These are all basically random samples. What are non-random samples? We'll do that when we get back. That'll be Wednesday because Monday you have the day off. I hope you enjoy your long weekend. I will see you all then.